Continuing on in section 4.1, feel free to pause here and give this a try if you'd like. We're going to graph each function and then determine how it's a translation of the quadratic parent function. So if we look here, we have a plus 3 at the end. It's after our x squared, so it's the value of our function, parent function, plus 3. It's going to change the value, which means our output, by going up 3. So we start off here with our parent function at negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And again, we get that by plugging those x values into our parent function. Now, each of those points, we're going to move up 3. The entire function is being vertically translated up 3 units and ends here. If you're ever not sure if what you did is right, plug in a value and check. Pick a value for x. Plug in 1, for example. 1 squared is 1, plus 3, 4. Okay, it checks. So we can check there. So how is it a translation of the quadratic parent function? Well, g of x is the graph of our parent function, y equals x squared, except it's been translated vertically. And we went 3 units up. H of x here is also a translation of our parent function, y equals x squared. So I'm going to start at x squared for my parent function here. Now we're looking for our x changed. Okay, the input changed. So in order to get the same outputs, we need to figure out where our new input is. Well, in order to get an output of 0, for example, like at our vertex, we need our input to be 0. So x plus 1 has got to be 0, which means x is going to be negative 1. We're going to move it to the left 1 at negative 1. Okay, if we're on the inside and we go left because we had a plus. If it's a plus, we go left. Okay, so we're going to go left 1 unit for all of our points. Again, we want our output to stay the same. We just got to figure out what our new x has to be. So instead of x being 0, it would have had to have happened at negative 1, because negative 1 plus 1 gives me 0. When I square 0, we get an output of 0. So our outputs change based off our inputs, and we're looking for what input we put in to give us the original outputs. And we make that happen. Here it's translated left 1. So here, h of x is the graph of our parent function, y equals x squared, translated horizontally. Left 1 unit. In example 3, for the following equation, what are the vertex, axis of symmetry, maximum or minimum value, the domain, and the range? So we've got a lot of things we need to figure out. And right now our function's in vertex form. Remember, vertex form is y equals a times x minus h squared plus k. These values tell us a lot. Right now my a value is 3. That's my stretch or my compression. It's also a positive 3, which means it's going to be a happy face parabola. And that helps us out because it tells us whether or not we have a maximum or a minimum. Happy face parabolas have a small list value, a minimum. So we can pick out that there's going to be a minimum right away. We also need our vertex, our axis of symmetry, minimum or maximum and the value, domain, and the range. So a lot of stuff we're going to find here. It'll never be a maximum and a minimum. It's always one or the other. So you need to label it accordingly. Okay, always a minimum if it's a happy face. If it's negative and we have a sad face, we have a maximum value. My h value here is 4. the minus stays with my x as part of my formula, and h is 4. And that tells us two things. First of all, my axis of symmetry is a line, x equals, and I plug in that h value. Again, we need this x equals. It is a line, so we have to state that it's a line. X equals h. And here, that h value is a 4. My axis of symmetry is at x equals 4. Remember that my vertex is the point hk. My vertex here, the h value is 4. The x value of my vertex always matches the value on my axis of symmetry. My k value is -2. That's the y-coordinate of my vertex. Keep in mind, our minimum or maximum value is always the y-coordinate of our vertex, which here is -2. So my minimum is going to happen at y equals -2. So from my vertex, the x comes from my axis of symmetry, and the y is going to be my minimum or maximum value, depending on if it's happy face or sad face. My domain for parabolas, any quadratics, is always going to be all real numbers. We can plug in any x value we want here. We don't have any division by 0. We don't have square roots of negative numbers. We don't have any absolute values equal negative numbers. There's really no reason we can't plug in any of x. And when we look at our graph, this U-shaped curve, it's going to continue in both directions. So there's any x value that we want, we can plug in there, all real numbers. My range, though, is restricted. It's going to be all real numbers. Here I have a minimum value, which means my y values are going to be that value or higher. I could have any y value bigger than that because those arrows continue, but my lowest value is at that vertex. So here it's greater than or equal to -2. So my minimum value is what I use in my range. Because again, we're talking value like an output, and range deals with y's, our outputs. Now feel free to pause here and give this a try if you'd like. We want to know, what are the vertex, the axis of symmetry, minimum or maximum, domain, and range of our function. First thing I'm going to do is I'm going to figure out whether it's a minimum or a maximum. I have a negative sign, which means I'm going to have a sad face parabola. And I'm going to have a highest point, which means this is going to be a maximum. Now I can pick some information out here when I'm in vertex form. Remember, y equals ax minus h squared plus k. My h value comes from inside with my x. It's x minus, though, so that plus is actually a -1. Two minuses make a plus. So x minus -1. H is going to be -1. So my vertex has an x coordinate of -1, and my axis of symmetry is x equals -1. Remember, that's the line about which it's symmetric. And the x coordinate of my vertex and the x value of my axis of symmetry are always the same. The y coordinate of my vertex is my k value. So my vertex is at -1, 4. We also could have picked that through transformations if we wanted. We go left 1, up 4. So that point ends up at -1, 4. The maximum value is y equals the y coordinate of my vertex. Remember, the vertex is the point where it's symmetric about. It's our highest point here because it's a sad face parabola. And that value is at 4. So when it's in vertex form, our maximum is at 4. My domain is always all real numbers, unless we have some type of an application for a problem. But for this function itself, there's no x value we can't plug in. Remember, range deals with x's, range deals with y's. My range is going to be all real numbers. I have a highest value here. There's a highest y value this is ever going to be. And that y value is a 4. It could be equal to that, or it can be lower. If we look, these branches continue down. So I can be less than that forever, but it'll never be more than my vertex here. And it's the y-coordinate of our vertex with our range and with our maximum, because we're talking values, like outputs of our function. So here's all the information it asks for. It asks for vertex, axis of symmetry, maximum or minimum, and the value, and then the domain and the range. There's a take note on page 197 that talks about translations of parabolas some more. If we move horizontally, our change is to our x. It's our x value that's changing here, not our output. And I remember that because it's like it took our squared on our x and moved it horizontally over to make room for that h. Keep in mind, if it's x minus with our function, so the h value is the opposite of what's inside. That minus stays with the x, and that moves our vertex. It moves every point, but it changes our vertex here to whatever our h value is. Vertically, if it's after the fact, we already take our value of our parent function and then change it by adding or subtracting. So if we go up, it's positive. Down is where we go if it's negative. And if all we have is a plus value at the end, our k value becomes a part of our vertex, so 0k. We also can have both, so x minus h squared plus k. Again, the h on the inside is my left and right, and the k after the fact is our up and down. So here my vertex becomes hk, and we've already talked about that a little bit. So in example 4, we're going to use vertex form here and pick out our translations and then use those to graph. I have 4 different translations here. The negative is a reflection about my x-axis. So instead of being a happy face parabola, I'm going to have a sad face parabola. My 2, since it's being multiplied, is a stretch by a factor of 2. It's going to change my heights to be twice as far. On the inside, remember it's x minus h squared. So my h value is a 1. I'm going to go right to 1. And this is a horizontal translation. And my plus 3 on the end means I'm going to have a vertical translation. So the nice thing about vertex form is it's very easy to pick out where our vertex is. Here our vertex is at 1, 3, h, k. And we can use this information. So my parent function, again, is here. I'm going to do my reflection first. So instead of opening up, I'm going to open down. I'm going to go 4 down instead of 4 up. I'm going to go 1 down instead of 1 up. My vertex stays. I'm going to go 1 down and 4 down. Instead of being at 2, 4, I'm at 2, negative 4. Now, I'm going to take those values, I'm going to stretch them by a factor of 2. So, here I was 1 unit away. I'm going to take that 1 times 2 and be 2 units away. I was 4 units away, so I'm going to take that 4 times 2 and be 8 units away. I was 1 unit away. I'm going to take that times my stretch factor 2 and be 2 units away. And I was 4 units away. I'm going to take that 4 times my stretch factor 2, and now I'm going to go down 8. I can take now and move each of those points, right 1, up 3. So right 1, up 3, right 1, up 3. My vertex goes right 1, up 3. It should be at 1, 3, which is perfect. It is. Right 1, up 3, and right 1, up 3. And this is the graph of my function. and I'll continue this in another video.